Hello everyone, my name is Rachel Chanley, and today for my final project, I'm going to discuss with you ethical AI for predicting sleep disorders and cognitive decline. So let's jump into it. So my AI project uses lifestyle and sleep data to detect sleep disorders. So why are we diving into this? Well, because untreated sleep issues are strongly linked to cognitive decline. So the goal of my AI system is to provide an ethical, accessible AI that flags risk early for proper intervention. So the source of my data actually came from Kaggle on a sleep, health, and lifestyle data set. The format of my data is in CSV, has 400 rows and 13 variables. And some of the features include age, gender, stress level, sleep duration, BMI, and heart rate. And the target is sleep disorders, which include one of the three, none, insomnia, and sleep apnea. So you may wonder, why do sleep disorders matter? A lot of us are sleep deprived, whether it be from school, work, family, just a whole host of issues. But sleep apnea and insomnia are actually linked to several things. And some of the more common issues include memory loss, reduced problem solving skills, increased risk of Alzheimer's, and AI as an early detection tool supports preventive cognitive care. So when I pre-processed the data, I dropped unused columns. Encoded categorical features include gender, occupation as a few. Scaled numerical data includes sleep duration, heart rate, and I did my split into a training and test set of 80-20. And as far as my model choice, I chose a random forest classifier, and this handles both categorical and numerical data well. And it does have a built-in feature importance for transparency, excuse me, and the model accuracy is 88%. So I will get to doing the demonstration towards the end, so I'm going to jump ahead a little bit. In my model, it has a 88% accuracy rate. And for the insomnia, the accuracy rate is it's pretty high, 95.5%. And for sleep apnea, it's at 84.6. And this model actually showed a very strong ability to detect real-world sleep issues. Okay, so class 2 is sleep apnea. Once again, I had a pretty good, outstanding performance, and the model was actually nearly perfect at catching sleep apnea, which is pretty critical because it's often underdiagnosed and strongly linked to long-term cognitive issues such as memory loss. And as far as insomnia, it had pretty good precision at a rate of 0.85. And this means the model is good at avoiding false positives, but misses some true cases of insomnia. So you may have some false negatives. So it could be improved with more balanced data or perhaps additional features related to mental health or anxiety. And class 0, no disorder, was a pretty solid balance at 0.76. And it showed that the model can also reliably identify healthy individuals. So with the ethical development of this, I had removed personally identifiable data. I used a balanced sampling for fairness, and I prioritized explainable model, random forest, and I did avoid biased or opaque methods. Okay, so the ethical use of this AI is intended for healthcare professionals. It's not for self-diagnosis. It can be integrated into telehealth platforms. It promotes informed consent and transparent reporting. And AI decisions should always be reviewed by a human expert. So the ethical and practical value of my model, clinical screening tool. So this can be used by primary care physicians or neurologists or sleep techs to flag high-risk individuals for further testing. The ethical design of this. So my model uses non-invasive, anonymous lifestyle data, minimizing harming individuals and protecting privacy. And it does support early intervention. So by identifying insomnia or sleep apnea early, it helps prevent downstream cognitive decline, and it does support the ethical principle of benefits. So benefits is focused on the well-being and benefits to others. Okay, so some final thoughts. This AI is an early warning system to protect long-term brain health. And it's simple, ethical, and built for real-world application. Okay, so let's get into the good stuff and see the model demonstration here. Okay, so I wrote my program actually in a Jupyter notebook utilizing Python. So I'm going to restart my kernel and rerun all the cells. Okay, it's thinking, so bear with me. Okay, here we go. All right, so I have in my comments here, this is for sleep disorder prediction AI system. Okay, so I did need to import necessary libraries such as Pandas, Skitlearn, and you can see here Seaborn, Matplot. And this is my data set, the CSV file that I had downloaded from Kaggle. So in this area here, I was showing the first 5 rows, the information analyzed, and you can see it says the gender, it identifies the age of the individual, occupation, sleep duration, quality of sleep, physical activity level, and so on. Okay, so with the pre-processing of the data, I did need to drop some columns that were not useful or duplicates, such as person ID, not important, blood pressure, not important. And this is where I did some encoding with the categorical variables to numerical values. And this is where I'm showcasing the encoded data that we're going to analyze. Okay, this is where I am defining the features and target variable. And this is where I'm splitting the data into my training and testing sets. Okay, here are my numerical features. And this is where I'm completing the training for the random forest classifier. Moving forward, our predictions. And we're going to evaluate the model's performance by printing the classification report. Here's our confusion matrix. And we want to check to see which features are important to the model. And as you can see from here, BMI category is quite high, but beyond just focusing on some of this with the occupation and so forth, we are really focusing on the sleep duration of this.